Hi, I'm Thodoris Papakonstantinou, researcher at the Institute of Medical Biometry and Statistics of the University Medical Center Freiburg, Germany. I want to thank the organizing committee of ESCMAR-Conf 2023 for giving me the opportunity to present NMA Rank. NMA Rank is an R package for answering complex hierarchy questions in network meta-analysis. You can find the methodology behind it in the 2022 BMC paper. The source code is also available at GitHub, and you can install it in R as a CRAN package. In this tutorial, though, I will be using NMA Rank Shiny app located at shinyapps.io, which makes things much easier. Co-authors of NMA Rank are Gito Schwarzer and Adriani Nikolakopoulou, both colleagues at IMBY. But first, a small introduction in network meta-analysis, or NMA for short. In NMA, one meta-analyzes multiple treatments simultaneously, as shown in this example, which I will be using in this tutorial. This example is the Woods 2010 dataset of NetMeta, the popular package for performing NMA developed by Gito Schwarzer. You can learn more about NetMeta in a dedicated workshop of the conference. In this meta-analysis, the outcome is mortality for COPD, and it includes 4 treatments as shown in the network plot. The forest plot and league table, as returned from NetMeta, show that SFC has the lowest mortality with an odds ratio of 0.29 compared to placebo. NMA Rank was built to address the fact that there is no unique best metric to summarize treatment ranking from NMA results, as shown by Salanti. Every metric answers a different hierarchy question with varying degrees of relevance to the decision maker or stakeholder. So, in this tutorial, I will be posing 5 questions in 5 levels of complexity to showcase the use of NMA Rank. It is important to note that NMA Rank assigns probabilities to quantify certainty of statements about the mean effectiveness of treatments. Let's start with the most basic question at level 0. The snippet shows how to perform NMA with NetMeta and get the league table and forest plot. Since small values are desirable, we can see that SFC is the best treatment with the smallest odds ratio, followed by salmeterol, fluticasone and placebo. But of course, this hierarchy is derived only by the mean effects and does not take into account uncertainty. So level 1. What is the probability of SFC being the best? Let's open the NMA Rank Shiny. First, a small introduction on the app. There are 2 tabs, the Data Management and the Analysis or Main tab. The app has the Woods 2010 example preloaded, so you can use it right away. You can also download the example, which contains 2 tables, one for the NMA effects and one for their variance-covariance matrix as TXT files. You can use the downloaded example as a template to upload your own data. Since the Woods example is already loaded, I can move on the main tab. Here first I have to define small values as desirable and then define my question. This is done by the condition box. In NMA Rank, the hierarchy question is described as a condition or set of conditions that a hierarchy must fulfill. This is done by using these predefined logical functions given in the menu. I will choose the specific position and write down SFC and keep position at 1. I then have to check the condition by clicking Check Choices, and since there are no errors, I can proceed in the calculation of the probability, which is around 60%. As you probably know, the probability of being the best metric takes into account only one tail of the distribution and thus can benefit in precise treatments, such as in the example here where T3 is the most probable of both being best and worst. On to complexity level 2. Let's ask, what is the probability of the hierarchy given by the min effects? In the app, I click Reset and select the same hierarchy function. Then I have to type the hierarchy in the treatment input. If I make a mistake, I will get notified, and then I correct it and check again and proceed to the actual calculation. I of course get the same probability as in the first row of the hierarchy matrix, so no surprises here. But we showed in the BMC 2022 paper, min effects don't necessarily give the most probable hierarchy. So we should have this in mind when interpreting NMA results. In this example, the hierarchy of min effects is T3, T2 and then T1. But as shown in the density plot function, it has only 15% probability against alternative hierarchies with 25% probability of being true. Level 3. And now I'm interested in the ranking of 2 or more treatments. First, let's ask NMA rank Shiny what is the probability of fluticasone being in the first 2 positions. I reset, select better equal, type in fluticasone and select position 2. I get around 44%. How about now asking the probability of fluticasone being in the last 2 positions instead? Well, all I have to do is select the opposite checkbox and leave everything else as is. Okay, now how about asking what is the probability fluticasone is better than SFC? I reset, select retain order, add SFC, check and calculate, and I get 22%. Retain order works for any number of treatments and checks their relative order, ignoring absolute ranking positions. In level 4, we introduce the concept of clinically important value, or CIV. By CIV, we define a threshold value below which treatments are considered to be equal. So, the bigger CIV function gives the probability of a relative treatment being bigger than the given CIV. As an example, let's ask what is the probability that the odds ratio of fluticasone versus SFC is bigger than 1.11. We first have to convert the odds ratio into log odds ratio, which gives 0.1. This is not necessary, of course, in the case of mean differences and other effects that are already in an additive scale, but in any case the app will guide us. Another thing to note is that bigger CIV ignores small values parameter and always checks treatment 2 minus treatment 1 against the CIV. And finally we arrive at the last level of complexity, condition composition. In order to be able to describe all kinds of possible inquiries, NMA rank gives the possibility to compose as many conditions required into a single condition. This is done by using the AND, OR, and XOR operators. These operators combine their left part to the right one. Each part can be a single condition or a combination of conditions, thus forming a tree, and demands both part left and right to be true, or just one, and XOR strictly one part has to be true. Since this can seem a bit complicated, I suggest using NMA rank Shiny that takes care of the syntax for us. So let's combine some of the previously mentioned questions and some more. Let's ask NMA rank Shiny, what is the probability that the odds ratio of fluticasone versus SFC is greater than 1.11 and fluticasone is in the top 2 positions and placebo is last? The app allows a maximum of 4 conditions to be combined, and only the predefined structure shown here. We first have to define the first condition with a bigger CIV function. Then choose the AND combinator and define condition number 2 for Fluticasson with better equal. Again the AND combinator, and for condition 3 select placebo in the 4th position. We check the query and can see the condition that is going to be sent to NMA rank. Hit calculate. So, in this tutorial, I showed how to use NMA rank through its Shiny app and creating hierarchy questions in 5 levels of complexity. I hope you enjoyed the video and see you soon.